Most of the data on the internet is unstructured. Nearly 80% of the data is unstructured. What is unstructured data? The data which cannot be neatly stored in the relation databases, consider those data as unstructured. For example, images, videos, documents, they are all unstructured. Whenever we store these unstructured data in our databases like blob storage or the S3 buckets, we also store other information. For example, in this case, suppose we want to store these pictures. We could store directly in our blob storage, but against those images, we also store information like animal, color and tags, and we call them metadata. Why we need this metadata? Because just by looking into this pixel value, we cannot find similar images, we cannot analyze anything, we cannot perform any search just on the basis of these pixels values. That's why we always store metadata against all these unstructured data. But even though we are storing this metadata, we cannot perform the semantic search. We could just perform exact search, some like searches or even fuzzy searches to a certain extent. But search based on the context is not possible with the relation database, whether it's structured or unstructured data. So we need some kind of a data structure which we could use to perform semantic search. Enters the vectors. How are vectors generated? We take all our data, whether it's structured or the unstructured, we pass into these embedding models, and these embedding models generate these vectors. Consider these vectors as a sequence of numbers and dimensional matrix. It could be 2, it could be 3. The longer, the better vectors it is. And what is this embedding model? Consider these embedding models as some kind of a machine learning models which perform some mathematics. But we should not be worried about how this mathematics is done. We should be worried about how to use these models as an application developer. Suppose we feed this 4 information into our embedding models. We could clearly see if we provide this cat information to this embedding models, the vectors generated by these embedding models will lie close to each other. For the dogs, the vectors generated by these embedding models will lie close to each other in an n-dimensional space. For visualization, consider this orange as the cats and the purple as the dogs. So you could see these orange vectors lie close to each other and these purple vectors lie close to each other. This is an example from my project. We have this content, outware contents, and we have created these embedding models with the help of OpenAI. The model which we have used is text embedding ADA002, and you could see we have created this sequence of numbers, and the dimension of this matrix is 1536. The longer the dimension, the better the vectors and the better the semantic search happens on these vectors. We will use the PGVector store here, which is a plugin of the PostgreSQL to store the embeddings. We sometimes call vectors as embedding also. The use case for these vectors is it helps us in the semantic search, as we are going to build this in our playlist. We could also use in the recommendation engine. Suppose on the Amazon you shop for some products, then the Amazon will start recommending you for some other products as well based on your previous history. We call this a recommendation engine. Also RAG, retrieval augmented search. This is out of the scope of this playlist. We will see in some other videos about this RAG. Let us see how the semantic search will be performed in our application. We have 500 products in our databases. What we are going to do, we are going to feed all these 500 products in the embedding models and generate these embeddings or vectors, of course of 1536 length. Then we are going to store all this vector in our vector store. That is the step number 1. Consider the step number 2. Suppose the user enters something in the text search box so that he could find similar products. What we are going to do, we are going to grab that text from the text search, put in the embedding models and generate the embeddings. Once we have got this embedding, we are going to feed this embedding into the vector store. It's the responsibility of the vector store to perform similar search and return similar vectors to us. Once we get these vectors, we return these vectors back to the users, and the user is able to view the similar products. This is as simple as that.